Okay, so you're leveling up. This is elimination part 2. So we've covered the basics of elimination, that you can have it in the slope-intercept form. So you have the y equals equations, that format on both equations, and then all you had to do was subtract one from the other. You've also experienced where you've had two of the same coefficients, but maybe one was, they were both positive, and you just had to turn the expression negative so that you would create an elimination situation. But what happens when you need to use elimination, but there are no pairs of coefficients that are the same? In this case, you have to create your own set of expressions that has a pair of matching coefficients. So in this case, we now have to create our own magic. This is where we need to dig into our 6th grade learning and remember what it is to have a least common multiple. So looking at the first example, I see x has a coefficient of 1 and x has a coefficient of 4. So what coefficient could they possibly share in common as common multiples? Or not, least common multiples. Well, they could both have 4s for coefficients. So how would I go about creating a 4x in the top equation? Well, it means I'd have to multiply everything in that equation by 4. And that would give me the 4x that I need. So remember, I said you could do anything you want to the left side as long as you do it to the right side. And it has benefits to multiply by 4. Some things that we can do, just because we can doesn't mean we should, right? But in this case we should, because it's going to give us an advantage. So now I'm multiplying, I'm distributing that 4 times 1x, 4 times negative 3y, and I now have negative 12y, equals 2 times 4, which is 8. Okay, so what just happened here? I just multiplied the entire equation by 4. Now I have a 4x plus 7y equals 27. And I can subtract one from the other. And it really doesn't matter which one I subtract from, as long as I subtract the entire equation. So I'm going to go ahead and do it to the top. Since we're already making changes to the top equation, why not keep it going? Now that gives me negative 4x plus 12y equals negative 8. And now again, just carry over my equation on the bottom. And I'm now eliminating, which is the whole point of this process, my x variables. I now have 19y and equals 19. Okay? So now I'm going to divide by the coefficient of my variable, and y equals 1. Now I substitute back in, because we're just never going to get away from Mr. Substitution, aren't we? And that is x minus 3 times 1 equals 2, x minus 3 equals 2, x equals 5. Because I plus 3 to both sides to eliminate the negative 3. And my final ordered pair is 5, 1. Okay, I know your head's probably spinning, but we gotta do it again. So again, we're looking for, let's go on down to number 3. We're looking for the least common multiple. As we examine the two equations, we see that the coefficients of x kind of guide us. 4 is a multiple of 2. 2 times 2 is 4. So if I go ahead and multiply by 2 everything in the left expression and keep the balance by multiplying by 2 to the right expression, I'm going to come out with 4x minus 10y equals, let's see, 40 times 2 would be 80, so that would be 78. Okay? Now I have a 4x minus 3y equals 43. Now remember, the name of the game is elimination. That's the whole point of doing this, is to get one to eliminate the other. And right now we have two 4x's, positive 4x's. So how can we set this up so that one will eliminate the other? Well, we're going to subtract. We're going to basically multiply through by a negative 1 and subtract. So that means 4x minus 10y equals 78. And notice this time I'm subtracting the bottom one, not the one I altered, but it doesn't matter. As long as you're subtracting one from the other, that's all that matters. So basically all their signs flip, and now I have a negative 4x, a positive 3y, and a negative 43. And now the x variables eliminate each other. I'm left with negative 7y equals 35, positive 35. And I divide both sides by negative 7, and y is equal to negative 5. I now have to stick this back into one of the two of my original equations. It doesn't matter which one. So I'll just place it in the first one. Negative times negative is positive. 5 times 5 is 25. Subtract 25 from both sides to zero it out on the left. 2x is equal to 14, divide by 2, and x is equal to 7. Therefore, my final ordered pair is 7, negative 5. You might like this way better than substitution. It is easier to use substitution in the example of, let's say, number 4. When you already have a variable that's isolated, you just have to subtract 4x to both sides and then just sub in the expression. This way works best when you're trying to create multiples, and you could see in number 3, this would be a nightmare to use substitution for. Because not only would you have to do some rearranging, you'd have to divide by the coefficients of y or x, and it can get messy. Then you're dealing with a lot of fractions. But elimination has its place. Substitution has its place. They're both tools that have their place. If you prefer one method over the other, that's okay too, because they both work. All right, happy practicing. Let me know if you have any questions.